All right, guys, we're just going to get a quick little start in the 5.6 notes section. And so here's what we're going to do. I've got this brief little introduction, and then there's a Desmos activity I want you guys to do some exploring, and then we'll go through more lesson together. So you're going to see this kind of split up maybe a little bit differently. I'm going to have this is kind of a brief lesson here, more of, and honestly, I'm going to ask you guys to do most of it yourself because you have the tools for it. But then there'll be a Desmos activity that I will link on our Canvas page, and you will need to make sure that you complete that before watching the next lesson, okay? That way you really have a little bit of a deeper understanding than what these notes provide, okay? So anyways, what we've got going on here is graphing polar functions. So we spent the last few videos talking about how to graph the points on the polar plane, but this is actually plotting full-on functions, equations, okay? They look a little odd, all right? And the, the reason why you can't always tell if something is a function or not by using the vertical line test is strictly because of this lesson. So we've talked about that at the beginning of the year, that the vertical line test is not always the best test of whether something is a function or not, because what we have is what's called polar functions, and these do not pass vertical line tests, okay? But they are technically functions. So we're going to kind of see what all of this turns out to be. What we look at when you tell if something is a function is you look to see, does each input only have one output, or is there more? So that's what you've got to look out for. Okay. So in my example one, we've got an equation, 3 minus 3 sine theta. And they said that we're supposed to sketch this on the axis below. They've provided us with a table, and we're going to fill that in. But I'm going to just do a little bit with you and then ask you to try to finish the rest of it yourself. Maybe have a calculator handy just because it will help with some of these values, especially when you get like square roots in them type of situation. But yeah, okay. So on the first number, the first bit, what I'm looking at is, again, plugging in theta. Theta is like our input here. Even though we plot points, right? Remember, we plot, that's not how you spell plot. Let me try that again. Plot points as our theta. That's how we write them. R is first and theta. But theta is the input. All right. So whereas normally we think of like X and Y, X was the input, Y was the output. This is like their order is switched. I don't know why they decided to do it in that order, but they did. So theta is our input value. And so when we input that in the function, we see what do we get as an output. Okay. So that's what we're going to see here. And then remember, you plot your points R theta. Okay. So I'm going to do a couple of these with you, and then I'm going to let you guys try it yourself. And see if you guys can figure out how to do the rest of the table and plot your graph on the polar grid. Okay, so let's take a 0 and plug that in. If I plug 0 in for theta, right, I want you to imagine what we've got going on there. If I plug in a 0 for theta, you'll be calculating sine of 0, right? I was going to try to find a little sticky note. Second. This will work. Okay, so if I plugged in 0, right, then I would be looking at 3 minus 3 sine of 0. So what we have to do is imagine on your unit circle at 0, what is the y value? Well, the y value is 0 there. So sine of 0 is 0. This would be 3 minus 3 times 0. 3 minus 0 is just 3. So when I plug in a 0, we get 3. All right, now I'm going to do another one with you really quick. Okay, let's do pi over 6. You may want to have some scratch paper handy just so that you're not like junking up your whole paper. I don't know. If I plugged in pi over 6, 3 minus 3 sine pi over 6, right? Then we're going to have 3 minus 3 times sine of pi over 6. So sine of pi over 6 is 1/2. 3 minus half of 3 is 1.5. 3 minus 1.5 is 1.5. I am getting decimals on this because it's going to make your stuff in the long run easier to graph. So if you leave it with square roots in it, or if you leave it as a fraction, sometimes that's harder to graph with. So everything is going to get changed to have decimals instead of square roots and fractions, just to make the graphing easier. Okay. All right, I'm going to do one more with you, and then I'm going to leave you guys to try the rest of these on your own, and then I'll show you what we should have at the end. Okay. All right, we're going to plug this one in. If I have 3 minus 3 sine pi over 4. All right, 3 minus 3. Now, sine of pi over 4 is going to be square root 2 over 2, which, like I was saying a minute ago, if you have the decimals and the fractions or the square roots and stuff like that, we're going to go ahead and use a calculator to get rid of it. So I think my brightness is too high on this. Let me try to dull it down a little. It's a little better. Okay, so I'm going to type this in. 3 minus 3. And honestly, as long as this is in the radian setting, you could just type in from the beginning 3 minus 3, and then you could do just sine of pi divided by 4 if you wish. It will give you the rationalized fraction there, but your answer should be about 0.8787-ish, right? So I'm good with you using a calculator for some of this. Again, you can just type it in and say like, okay, so for the next one, if I typed in, as long as your calculator's in radians, if I type in 3 minus 3 sine and then plug in pi divided by 3, then it gives you that decimal 0.4019. Okay, so we can do that, especially for things where you're going to get those irrational numbers. Okay, so what I want you guys to do, we've done some of this together, but I want you to fill out your table, and then I want you to come back when you're ready to check your answers. Okay, go ahead and pause the video and do that. Okay, I'm going to go ahead and fill this in with what we should have gotten if you actually worked this through. If you realize that you have all the correct things, that's amazing. If not, go back and try it again. Like I say, you can use a calculator to help you make sure that you get those proper values. And if you end up having questions and don't understand where something came from, then make sure to reach out to me and I will help. 213, 4.5, and I'm back at 3. Okay. Okay, cool. So awesome. We got a table of values. Now, how do we plot it? I'm going to help you plot like a couple of them, and then I'm going to need you guys to try the rest yourself, and then we'll see what the picture looks like. All right, so 0, 3. We're looking at if theta is 0, meaning that I am on this axis right here. I don't have any angles going up or down. And I'm going to go out to 3. Now, 3 is going to be halfway between the 2 and the 4, so this is not the best. This is personally not my favorite scaling for the polar graph, but I understand why they do it once you see the end of the picture. So here between the 2 and the 4, you're going to have your 3. Okay. Now here at pi over 6, 1.5. So pi over 6 is going to be on this spoke right here. Okay. Pi over 6 is on this little spoke. We're going to be at 1.5. All right. Now, 1.5. I want you to look in between here, between the origin and the 2, you've got your 1 in there. Your 1.5 is going to be a little bit further out. So it's going to be around in there. You got to eyeball it the best you can. It's not going to be perfect. Maybe around in there-ish. Okay. And then the next one we're going to do is pi over 4. So pi over 4 is this little spoke. And we're at 0.8787. So remember how I said between the origin and the 2, halfway between there is the 1. A little bit before that is going to be that one right there. So I know this looks a little weird. All right, pi over 3, we get 0. Here's pi over 3 right there. Okay, 0.4019. All right, so I'm thinking if 1 is in here, then this is going to be in there-ish. And then at pi over 2, 0. Pi over 2, my radius is 0. We're going to be right there at what we normally consider the origin. So just graphing that little bit, we get this kind of rounded shape right there. That was just going up to here. Now, I want you guys to try to pause the video, try to graph the rest of this, okay? And then come back when you're ready to check what your graph should look like. Because I'm just going to throw one up there that I've completed. Okay? All right. Pause. Hopefully you've already graphed it or you've tried it. It should look something like this. It's almost like a heart shape, except this is pretty solidly round at the bottom, or it should be if it's done correctly. So it shouldn't really like come to a point. It just kind of grazes by through here. So, but it does kind of look a little heart-ish if you look up at the top. It's got that kind of shape. All right, that is your first polar graph. Now, we're not going to make a t-table for everything. We're not going to graph every single little thing that way because you can identify these graphs and once you recognize a bunch of patterns. So your activity on Desmos that I told you about, that is what you need to do next. I am linking it right after this video on your Canvas page. So please make sure that you check that out and do that activity. And then come back when you're ready to learn a little bit more. All right, I'll see you in the next video.